we talked about one form of energy, and that was mechanical type of energy. Today I would like to talk about the second kind of energy, and that one is a thermal energy, or we call it the heat. In this section I would like to tell you what the heat is, what's the temperature, and how it's being moved from one location to another, and then move to a concept of thermodynamics and what are the laws that governing motion of heat and production of power. And then finally I would like to talk about thermal devices, things like engines, power plants, refrigerator, and so on and so forth. And eventually at the end I would like to show how these laws apply to the human body. What is heat? It seems like everybody knows what heat is. We definitely feel it, very, very easily when it's hot or it's very cold. But what is really the heat? It's not all that simple to define heat, as it is a very, very elusive form. And very closely related to heat is the concept of temperature. What do we mean by saying that the temperature today is 80 degrees or it is very hot? Let's look at the concept of the heat. The heat, the way that we understand it today, it took over 2000 years or longer before we get to this concept of understanding. Go back time of Aristotle. It's about 4th century BC. Aristotle believed in the fact that heat is a substance, just like water that flows from a high elevation to a lower elevation. Heat is a substance, it has a mass, and it goes from a higher temperature or hot to cold. Well, that's pretty simple. He would say, well, a log of wood, when you burn it, the heat is escaping it, and eventually it becomes cold. Not only the heat is escaping, the mass will be also reduced. You take a piece of wood, you burn it, the mass of the wood will be reduced. So to Aristotle it was very simple. Heat escaped this mass of this wood, this log of wood. Aristotle did not believe in actually atoms either. He would believe that mass is continuous. He would say there is no such a thing as vacuum. He has a famous saying that nature abhors vacuum. His argument was simple. If there is something empty, the mass will move from the place at which it exists to fill up that place, because that's the easier place, the more comfortable place to rest. So the mass will move from a location which existed to location which was vacuum. Therefore vacuum could not exist in the nature. So that also made a lot of sense to people. The same time, at the same period that he was living, another person by the name of Democritus would think the mass is actually, you can divide it, and divide it so much that you cannot divide it any further. So he called this atomus, which means indivisible. Well, the atom that we know today is somewhat different from that, but what in the principle of Democritus is that the vacuum exists. If you think of several balls and you put it together, you cannot put a chunk of balls or several balls without some empty space in between. So that would say, well, the vacuum should exist. So these were into total conflict. And anyway, Aristotle always won. It took about 2000 years until Antoine Lavoisier, a French scientist, he was doing some experiment. Few years back, they had found the element oxygen, and he took some mass, some alcohol, and some cotton inside a vessel. He covered the vessel, he burned the stuff, he let it cool down, and guess what? The mass did not change before burning and after burning. Well, he knew that at the time, that the reason that log of wood would lose mass is because all this product of the combustion would be evaporated and nobody could see those things, so that's why the mass was lost. Here, he did a control experiment and he showed the mass is conserved. So today we attribute the law of conservation of mass to Lavoisier. So if that's the case, then something was wrong with Aristotle's hypothesis. So he changed his idea, came up with the idea of caloric. The word calorie comes from that. Means that the heat is still a substance, but this substance cannot have any mass. Now, then, the idea of Aristotle was still valid. Heat is a substance going from higher temperature to lower temperature, but this substance does not have any mass. About 50 years later, John Dalton, he was actually doing some more experiment with a hot air balloon. He knew that if you take the balloon and you heat it, the balloon expands. Well, to Aristotle it was very simple. Why would it expand? Because you could add the heat to it. Heat had a mass, and therefore mass could not go any place, and the only thing they could do is pushing the walls of the balloon outside, so the balloon expands. But if Lavoisier showed that the heat cannot have any mass. So Dalton's explanation is that the same mass that occupies some space now is occupying the bigger space. How is it possible? The only way that you can explain this is that there are some vacuum now created. Again, another nail in the coffin of Aristotle. So now you have to look at the heat as something that expands, and when it expands creates this there is a white vacuum in space. So the idea of Democritus was the correct one as compared to the Aristotle. Eventually somebody by the name of Benjamin Thompson or Count Rumford, he showed that the heat, he was looking at boring of the cannon. He was from the Concord, New Hampshire. He was the British that came there, was fighting in the American Civil War, eventually got tired of it, sided with British and got tired there too, moved to Germany. He was very smart and a good military man. He was put in charge of the boring of cannons, and when he was looking at this, he saw that the cannon was cold, and eventually when you start to bore into it, then both the cannon and the shaving, they become hot. So that could not be then from a hot object to a cold object, and he eventually concluded that heat is due to motion, is because of the relative motions of the two atoms. Today I know that if you take a drill bit, as the drill bit moves, the heat is produced. Easier way to say that, if you take your hands and you rub two hands against each other, the heat is produced. Both hands were cold, you're rubbing it against each other, both hands get warm. So heat means motion, the motions of the molecules. That was the principle of atomic theory, and that's the concept we accept today. So heat is a sensation of the warmth, but it is stronger in the higher temperature than the colder temperature. How much it produces then depends not only on the material, but also in difference in the temperature and in the thickness of the substance.